Okay, the nucleus of an atom is composed of a collection of different particles, and there are two types of particles. One of them I'm going to represent with a red dot. Those are called protons. Protons have a positive charge, and then there's another type of particle in the nucleus which are called neutrons. And they have no charge, or zero charge. So, if you take a typical nucleus, and if you could zoom in with a higher resolution microscope than we have, then we can imagine that we might see a little collection of neutrons and protons all clumped together in a little ball. Now, we can say a few things about this nucleus here just by counting up the number of protons and neutrons. All that we know about any nucleus or most of what we know, at any rate, about any nucleus is just found by counting up the number of protons and neutrons. So there are a couple of numbers that we use, terms that we use for the numbers of protons and neutrons. The most important one is called the atomic number, and it's called Z. Z is equal to the number of protons. We can also have another term which is N, that is just the number of neutrons. And then finally we have another number which is called the mass number, because it primarily determines what the mass of the nucleus is. And the mass number, we give the letter A, and that is the sum of the number of protons and the number of neutrons. So we could write that the mass number is Z plus N. Let's take a look at this nucleus here as an example. So Z for this nucleus is a number of protons, 1, 2, 3. Z equals 3. N would be the number of neutrons, and that's 1, 2, 3, 4. And then A is the mass number, which is the number of protons plus the number of neutrons, so that's Z plus N. 3 plus 4 is 7. 1, 2, 3, 4, 5, 6, 7. A equals 7. Now, there's another way of writing down what this element is. We can find that by looking at a periodic table. Now, if we look at a periodic table for this element, we find something like this. If we look at a periodic table, we will find that it's composed of a series of boxes, and at the top of each box is a number. The number we're looking for is 3, because the top number in the top of each of the boxes on the periodic table, this is from the periodic table, the number up here is the atomic number. The atomic number is 3, Z. And inside the box where you have an atomic number 3, on every periodic table you will find Li. Li is called the chemical symbol and it's a shorthand. In this particular example, it's just, Li is simply short for lithium. Alright, that's fine. So now we have a chemical symbol which corresponds to Z equals 3. We also have this N equal 4 and A equals 7. So we also want to be able to write down, we'd like to have a shorthand to write down what this nucleus is. And so the conventional way we do it is like this. I write down the chemical symbol Li. That tells me that I'm dealing with a lithium atom, and the lithium atom must have 3 protons. 1, 2, 3. There it is, 3. But I also want to write down what type of lithium atom is, and that, in order to do that, I need to write down the mass number. So the convention is that we write the value of A up on the upper left, like that. So lithium 7 is shorthand for telling us that we're looking at this type of nucleus. Now, there are other types of lithium nuclei, so let me give you another example of that. Suppose instead of this, I was to change the number of neutrons. So let's make another lithium atom. Here, I'll have one with 3 protons and only 3 neutrons. 1, 2, 3 neutrons. Okay. How would I write this one? Well, it's still lithium because it has 3 protons. 1, 2, 3. Z equals 3, right? What's A in this case? Well, A is 1, 2, 3, 4, 5, 6. So I would write the name of this nucleus as lithium 6. Now, there's another term you need to know here, which is that lithium 6 and lithium 7 are both the element lithium, so both of these things compose are the nuclei in a metal of lithium, which has about the same chemical properties, but they are different isotopes.